Hi guys, my name is Trung Nguyen, and today I'm going to go over drawing a loose dot diagram with an expanded octet. Okay, so there's three major exceptions to the octet rule. There are molecules with more than an octet. Our example here is sulfur hexafluoride. Notice that sulfur has 6 bonds around it, and each bond has 2 shared electrons, which means sulfur has 12 electrons instead of the usual 8. Next, we have molecules with less than an octet. Our example here is boron trichloride, in which boron only has 6 electrons. Finally, we have molecules with an odd number of electrons. Our example here is nitric oxide or nitrogen monoxide, in which oxygen has an octet, but nitrogen only has 5 electrons. And don't forget the lone electron is called a free radical. Okay, so here's our strategy for drawing the Lewis structure. This is going to appear as almost like a caption when I'm doing the problem. Okay, so for polyatomic ions and drawing the Lewis structures. In this case, you first consider that sulfur has 6 valence electrons and oxygen has 6. There are 4 oxygen atoms for a total of 30 electrons, but you also add 2 for a total of 32, because -2 is the charge, and -2 signifies that there are 2 electrons in addition to all the valence electrons. For a positive polyatomic ion like ammonium, you would subtract. Okay, so for formal charges are not the actual charges on a molecule, but assigning the formal charge to atoms within a molecule helps with arranging the Lewis structure in the most correct way. Okay, so let's jump right into it. Sulfur tetrafluoride has 34 electrons because fluorine has 7 electrons each and sulfur has 6. So 7 times 4 plus 6, like the equation you see there, is 34. Start by connecting the sulfur atoms, the fluorine atoms, completing the octets with fluorine atoms. Then place the extra electrons to the central sulfur atoms. Sulfur is in the middle because it's usually presented, the central atoms usually presented first in the formula. And the less electronegative atom is usually the central atom. And we know that fluorine is the most electronegative, so sulfur has to be the central atom. Okay. Every bond is 2 shared electrons, so now we have used 8 electrons by connecting the sulfur and the fluorine atoms. Okay, now completing the octets for each fluorine atoms would make the total number of used electrons by 32. So there's 32. Here's where the exception is. To get a total of 34 electrons, simply place the remaining electrons in the central atom, the sulfur atom. Okay, so here's a nice neat table to figure out the formal charges, and the equation is very simple. We see that 0 is what we ideally want for all formal charges, so we do not need to remove or change anything. And sulfur tetrafluoride, no matter how you rearrange it, does not have a resonance structure. Okay guys, thank you for watching this video. I'd like to thank the people at ChemDoodle and the professor who oversaw the making of this video, my chemistry professor, Dr. Rogers. Thank you guys.